Hey, today we're going to be doing scientific notation. Listen with your eyes and ears, please. Eyes are here, ears are up here. Scientific notation today. Many of you have had experience with it, but we're going to go through a quick review of it, and then tomorrow you'll review all of 8.4. All right? Very good. So get the scientific notation, the learning goals down, read your cool comic, make sure you laugh. Thank you. Thank you. All right, Cavallero, Algebra 8-5. Hey, scientific notation. How many have done scientific notation before? Okay. So there are a lot of different things we're going to review on it. Scientific notation we use when we have really big or really small numbers. It's used a lot in science, hence scientific notation. Notice number one's done for you. Okay. They've transform 4,350,000 to 4.35 times 10 to the 6th. Notice the example up here says a number with one digit to the left of the decimal point multiplied by a power of 10. That is scientific notation. So you're only allowed to have one number to the left of the decimal. In this case, it's the 9. So when I'm looking at 4,350,000, we're trying to get the decimal in between the 4 and 3. Okay? So if I'm going on to say number 3 here, everyone give that one a shot. Tell your neighbor where that decimal has to end up. Let's just worry about where the decimal has to be right now. Okay, Michaela, where does the decimal have to end up?
Between the 7 and the 2.
You've seen the 7 and the 2 is what Michaela says. How many agree? Very good. Between the 7 and the 2, where is it right now? Kay or Austin, where is it right now? On the very end. It's right here. If we don't see the decimal, it is right here. Once again, listen with your eyes and ears. So if you're just cranking away on your assignment, let's make sure you're doing it right first. That way you don't create more work for yourself. It's at the very end. Okay, so to get it from here to there, how many spots do we have to move? 10. Okay, so some of you counted it off. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, many of you will notice that every 3 digit, there's a comma. How many have noticed that? Those are like road markers. It makes it quicker to count. 3, 6, 9, 10. Okay, so we have 7.214. We don't need to worry about all those zeros. Times 10 to the 3, 6, 9, 10th power. To the 10th. Yeah. Okay, now pause for a minute. Let me give you the rule so that you guys can, I know that many of you think you're experts on this, but here in about 5 minutes you're going to be confused on different parts. So let me give you the rule. I appreciate everyone wanting to write it down really fast. If this number right here, if the number you start with gets smaller, then your power gets bigger. Don't think about if I move this way it gets positive, if I move this way it gets negative. Just think of it this way. If the number you're starting with gets smaller, your power must get bigger. Everyone see that? This number started at 72,140,000,000. It's now at 7.42. It got much smaller. Okay, so since that got smaller, my power had to get bigger. Here I'm at a power of times 10 to the 0 power. Okay, right now I'm at 10 to the 0.
How about number 13? Power would be bigger.
Well, is your number going to get smaller or bigger? So where's your decimal on 13?
Between 1 and 2.
That's where it needs to go, right? Where is it right now?
0. Yeah.
It's right here, right? So we need to move to there. So to go from 128,000 to 1.28, did my number get bigger or smaller? It got smaller. So that means when I multiply a power of 10, the power of 10 had to get. If this number gets bigger, what happens to your power of 10? Right? And if this number gets smaller, what happens to your power of 10? it gets bigger. Okay, so that's times 10 to the 5th power. That is really, really blurry. Okay? Brina?
So when we got the 10 power number 3, I was looking at like number 1, number 2, and I don't understand how they got 6 and negative 2.
Right here?
Yeah.
Okay, let's check that out. So, Dan, go outside, please. Randy, go outside. You guys take your work with you. Grab some paragraphs on the way out, please. Okay, so we're right here. We're going from this spot to this spot, right? We need to get to the 5.63. We started here. We moved 1, 2, 3, 4, 5, 6, 7. I'll bring them out to you. So we moved it 1, 2, 3, 4, 5, 6, 7, 8 spots, right? So the number was 0.000. It was really small. And then when we moved it those 8 spots, this number got bigger, right? So the power of 10 has to get smaller. So you go down in your powers of 10.
So where did they get the negative 8 from?
So you're always starting at times 10 to the 0 power if they don't show you times 10. So we're at 10 to the 0, and then negative 1, negative 2, negative 3, because this number's getting bigger.
Oh, okay.
So if this one gets bigger, we count backwards here. If this one gets smaller, we count forwards here. Okay, so thinking of it that way, when I'm looking at, say, problem number 11, is my power going to be positive or negative? It's going to be positive because my number needs to get smaller. Here, is my power going to be positive or negative? Negative, because the number is going to get bigger. So as your number gets bigger, so like I'm moving from here to there, from 0.00246 to 2.46, from here to here, that number, this number right here got bigger than that one, which means the power, to account for that, we have to make it a smaller power, meaning we're making it negative 1, negative 2, negative 3. Versus this one, where we're starting with a really big number, 93 million, okay, and we have to move it to make the number 93, or 9.3. So from 93 million to 9.3, that number got, 9.3 got smaller. So the power, to account for that, has to get bigger, 3, 6, 7. 9.3 times 10 to the 7th power. It's a tough 7 to read. Okay? What I want you to do right now is work through problems 1 through 20. Do your best. I'll be around. We're going to spend about 5 minutes on that. If you finish it, great. Check with your neighbors. Okay? Hey, just really quick, I had a good question, like on number 14 here. When they carry out, like you have 83 and then you have 001, you have to put every real number. You have to, as you're reporting this and you're saying, well, I got to move my decimal to right there. Well, that's 8.3. Now I've got to put all these digits because there's a real number right here. There's the number 1 there. Okay? There's a whole number that we have to put there. Guess I'm using the wrong terms. It's a whole number. Okay? So we have to put all of those numbers there. So if there was a 0 here, then we could just stop at 8.3. But since that 1's there, we've got to keep going. So it's 8.3001 times 10 to the 4th power. Okay? So keep asking questions. Good questions. Hey, let me show you number 7 since I've had a lot, or 3 questions on it now. All right? Or one's just like it. Taking a look at it, this looks like scientific notation, right? We have times 10 to the 2nd. What's wrong with it? Why isn't it in scientific notation? Elliot?
Because the first number is too big, it's supposed to be a single digit decimal.
Yeah, you're supposed to have 1 digit in front of the decimal, right? Remember, scientific notation, a number with 1 digit to the left of the decimal. So we have the decimal, we have 1 digit to the left of it. So on this one, right now, we have this times 10 to the 2nd, but we don't have 1 digit to the left of it, we have 3 digits. So we've got to move this, and this is why I was telling you guys earlier, think about what's happening with the number. So you went from 420 to now 4.201, right? So that part's now in the correct position. Did I get bigger or smaller?
Bigger.
Come on, everyone. From 420 to 4.201, did the number get bigger or smaller? It got smaller. Okay, we had $420. Now we have $4, right? It got smaller, which means if this number gets smaller, what happens to this power? It gets bigger. How much bigger is it getting? How many places do we move? 2. So it gets bigger by 2. Okay? Please understand what's happening. When you move your decimal, every time you move a decimal, it's like multiplying by 10. That's why we're saying times 10, times 10. So there was times 10 to the second, times 10 to the third, times 10 to the fourth. It just means you're multiplying by 10 one more time. That's why when I say divide by 100 or multiply by 100, I'm just moving decimals around. That's why we work on that. Okay? It's good questions. Keep asking them. Go ahead. Any questions on these, on the top part? Any ones you're stumped on right now? Okay. Hey, want to move on to the next section? Hey, even if you're not done with the top, pause right there. Let's look at the next part. Next part, multiply each of the following pairs of numbers. Leave your answer in scientific notation. Okay? So number 21. We got to multiply each part. So when you're multiplying here, multiply common pieces together. So if I'm looking at this and this, 10 to time, or 3 times 10 to the 5th, we can think of this 2 different ways. You can either think of it as a 3 and then times 10 to the 5th, which means 3 times 10 times 10 times 10 times 5 times. Or you can think of it as 3 times 2, which gives us 6, and 10 to the 5th times 10 to the 6th. Okay? So I guess if we're separating this, since everything's multiplication, we go 3 times 2 times 10 to the 5th times 10 to the 6th. 3 times 2 is 6. 10 to the 5th and 10 to the 6th. Well, think of what that means. 10 to the 5th means 10 times 10 times 10 times 10 times 10. That's a lot of 10s. That's our 10 to the 5th. 10 to the 6th is 10. Once again, a lot more 6s, right? Or a lot more 10s. 10 to the 6th. So 10 to the 5th times 10 to the 6th, this 10 to the?
11.
Yeah, it's 10 to the 11th. You have 11 of these. So kind of the quicker way to think of that is just, man, that's really blurry. Sorry. Kind of a quicker way to think of that is 10 to the 11th power. Just add those powers up. So this becomes 10 to the 11th. All right, so what is our answer? Well, our answer is actually 6 times 10 to the 11th. And it works like that because this number's between 0 or between 1 and less than 10. It's in between 1 and 10. Remember, our decimal's right here. So to be in scientific notation, that first number has to be greater or between 1 and it has to be less than 10. So 6.0 or 6. We usually put a 0.0 after it if it's just a whole number. So 6.0 times 10 to the 11th would be our answer. Right, I want everyone to try number 22. Give that one a go. Yeah. What's that? That's our answer. Yeah, because it says leave it in scientific notation. So everyone try 22. Yep. Okay, so what did we get? Let's see, Taylor, what'd you get there?
7.5 times 10 to the 3rd.
Good, 7.5. So 5 times 1.5 is 7.5. And then 10 to the 8th and 10 to the negative 5th, that brings us to, well, 8 plus negative 5 is 3. So 10 to the 3rd. Okay, how many got that? Well done. Any questions on it? Amanda?
No, I don't have a question.
Just stretching, okay. Hey, go ahead and work on through 28 there.
Yes, sir.
Okay, hey, guys, check out number 23, and then we'll move on to the next page. But most of you get the 24, the 6 times 4. And then 10 to the negative third and 10 to the negative 9. Right here. That's 10 to the
Negative 12.
it's 10 to the negative 12. Okay? Is this scientific notation?
No,
Why not?
it needs to be in point 2.4.
Good. So the decimal's here. We've got to move it over. It's got to be 2.4. Right? So that's 2.4. So this number got
Smaller.
smaller. So what happens to this one?
It gets bigger by 1.
It gets bigger by 1.
On the side.
It's 10 to the negative 11. So we got to add 1 to that power. Okay? So make sure you get that first number in between 1 and 10. Okay? Negative 3 and negative 9 is negative 12. And we're at 24. We got to move that decimal over 1.
Oh, okay.
So it becomes 2.4. So we add 1 to negative 12 to get negative 11. Okay? Any other questions on that section? All right, let's switch sides. Next side. Okay, the next set. Divide each of the following pairs. Pair of numbers, leave your answer in scientific notation. So just like we did in the previous set, if you're multiplying, you just multiply that part, the non-exponent part. So 1.8 divided by 6 in this case, so we're dividing. And then we're dealing with this part. We're dividing those two. So think of it this way. What's 1.8 divided by 6? Or 18 divided by 6? 3. So 1.8 would be 0.3. Okay? And then if I have 10 to the 5th on top of a fraction, so if you think of that as 10 times 10 times 10 times 10 times 10 on top, and then 10 to the 3rd on bottom, where do I have more 10s? Top. How many more? 2. So really I'm just doing subtraction there, right? I have more on top. So that's times 10 to the 2nd. Now if I had more on bottom, it would be times 10 to the negative whatever. So like on this one, I have more on bottom. Okay, we'll kind of get to that here in a minute. All right, but anyways, this scientific notation.
No.
How many say, yep, that's scientific notation, we're good to go? How many say, nope, that's not scientific notation, not good to go? Zach, why is it not?
Because it's a 0.
Yeah, because you have a 0 to the left of the decimal. This number's not between 1 and 10. We got to move it over 1 spot. That then gives us 3.0. So did this number get bigger or smaller? It got bigger, so what happens to our power? Gets smaller. So that's either 3.0 times 10 to the 1st, which we could also just write as 3.0 times 10. 10 to the 1st, just 10. So, hey, everyone give 30 a shot. We'll go through it.
10 to
What's that?
minus 10 to the 3rd power.
Could be. We'll find out. Okay, 4.5 divided by 9. Or 45 divided by 9 is 5. So that's 0.5 times 10. Where do you have more? You have more 10s on the bottom, right? You have negative 5 on top and positive 8 on bottom. How many more on bottom?
3.
Not 3. You have negative 5. And yeah, if you think of a number line, for those of you that can't do that in your head, you need to go and start thinking, hey, here's a number line, here's 0, here's negative 5, here's positive 8. the distance from this point to this point is, that's 13. 5 and 8. Okay? I have 13 more on bottom. If I have if I have a number on the bottom of a fraction, what power is that?
Negative.
It's a negative power. So that's negative 13.
Negative 12, move, decimal.
Yeah, then we got to move our decimal, right? This isn't scientific notation. We got to go over 1. So that number got bigger by a power of 1. So it's 5.0 times 10 to the, yep, this one gets bigger. This one has to get smaller. So does that go negative 12? Is that smaller than negative 13? Skylar, pay attention.
No.
What's better to 013 or 012? 012. That's bigger, right?
So,
Yeah, we got to subtract 1. Negative 13 minus 1 is negative 14. Okay. All right, go ahead and work on that section there. Give yourself a little time. I'll be walking. Hey guys, let's look at 33. Okay. I want to do a couple problems here. 7 divided by 2.8.
Is
2.5.
2.5. 10 to the 5th divided by 10 to the 3rd. Now, I've been saying, where do you have more? And some of you are really good at that. You recognize you have 2 more on top. Okay, the other way to do this, to figure your power, we just haven't got to this property, is just subtract the 2 numbers. So that would be times 10 to the 5th power minus the 3rd power. Right? So that's 2.5 times 10 to the 2nd. Okay? Now that gets a little more confusing when you do one like 32. Because you do 45 divided by 1.5, which is? It's 30. And then you go times 10 to the negative 3 minus what? Minus negative 6. It's not minus 6, it's minus negative 6. Now what happens when you have 2 negatives next to each other? Makes a positive. So negative 3 plus 6 is? That's 9. Or no, that's not 9. It's 30 times 10 to the negative or positive. What is it? Positive or negative?
Positive.
It's positive. That's positive 3. Okay, are we good?
Oh, no.
Positive.
You have to put the decimal and you have to make it less.
We got to move the decimal over. Yep, that one got smaller. So that's 3.0 times 10 to the. That one gets smaller, so this one gets bigger. Anya. Oh. Okay, so you're talking right here? Yeah, you subtract the top from the bottom, or you subtract the bottom from the top. So it's negative 3 minus negative 6. That's not negative 9. Negative 3 minus negative 6. 2 negatives next to each other makes a positive. Or if you're at negative 3 on a number line, and you go back 6, right? You're here at negative 3. You got to go back towards the negative 6 more spots. That's what subtraction is. That brings you to negative 9. Okay? So you got to use that 2 mark rule right there. All right. Try a couple more and we're going to move on to the next page. Keep asking questions though. Okay, guys, I want you to take a look at the next side, please. Hey, no one's usually we don't have people that are students that are huge fans of the story problem. Sorry. However, if we take a look at these, the best way I've found that students understand this is when you're going through and you're looking at these problems with huge numbers and scientific notation. First, if you have part of the problem in scientific notation, put the other part in scientific notation. So one thing to maybe make a note to yourself is put all parts in scientific notation. Okay? So number 41 says the Earth is approximately 93 million miles from the Sun. So 93 million miles from the Sun. How long does it take the light from the Sun to reach the Earth? Use the speed of light to be 1.86 times 10 to the 5th miles per second. Well, the problems are either going to be multiplication or division in these, because that's what we're practicing. So when we're looking at this, if you think of this as scientific notation, everyone write it in scientific notation. Okay, so what is it?
9.3 times 10 to the 7.
Good, 9.3 times 10 to the 7th. Okay, so we're 9.3 times 10 to the 7th miles from the Sun. The next thing to do is ignore the times 10 part. Okay, this has been, for a minute, just ignore the times 10 part and do the problem. So if I just read the problem like this, the Earth is approximately 9.3 miles from the Sun. Now that would be bad for us. However, let's just go with it for now. The Earth is approximately 9.3 miles from the Sun. How long does it take light from the Sun to reach the Earth if the speed of light is 1.86 miles per hour? So are we multiplying those two numbers? Or are we dividing those two numbers? Yeah, we're dividing there. Okay? 9.3 divided by 1.86. Which means we can now take this part, the 10 to the 7th and the 10 to the 5th, and divide those as well. We have to do that. Once we know what operation we're doing, then we put the other piece in. And now we have a problem just like we had on the previous page. Caleb, I think when I was going through this, I think we talked about you had multiplication. It's supposed to be division on that. That's my fault. Okay? All right. So what do we get there? 9.3 divided by 1.86. 5 evenly?
Yeah.
Dude, 5.0 times 10 to the 7 minus 5, or 10 to the second. And then we're dealing with how long? Well, are we dealing with miles per second, or seconds? It says how long. Is miles a time? No, that's a distance. Is seconds a time? Yes, so it's seconds. All right, everyone try number 42. Try it the same way, please. Okay, now some of you that are like, you don't like bacteria, you're kind of freaking out maybe a little now. It says there are 3.2 times 10 to the 7th bacteria on every square inch of the human body. If there are 2 times 10 to the 3rd square inches of the body, how many bacteria on the average body? So if there are 3.2 for every square inch, and there are 2 square inches, how do we do that one? We multiplying or dividing?
Multiplication.
3.2 for every square inch, and there are 2 square inches? Is that multiply or divide? That is multiply. 3.2 times 2 times 10 to the 7th times 10 to the 3rd. Yep, multiply it out. Come up with your answer there. Yep, your assignment is to finish that.
Thanks, McCoy.
You're welcome. The good news